physical timeline to build a semiconductor fab is no longer gated by cleanroom construction or lithography tool delivery. It is gated by the cryogenic cold boxes required to supply ultra-high-purity nitrogen. Cryogenic cold box lead times escalated from 16 months in 2018 to 34 months in 2023. This delay is driven by structural backlogs in high-alloy aluminum plate-fin heat exchanger fabrication. In 2021, air separation unit lead times crossed the typical fab construction window of 28 months. This shift placed industrial gas infrastructure on the primary critical path for new semiconductor projects. Plate-fin heat exchanger backlogs peaked at 90 weeks in 2023, up from 22 weeks in 2018. This reflects extreme concentration in specialized vacuum brazing and metallurgical welding capacity. Ultra-high-purity nitrogen consumption scales nonlinearly as transistors shrink. For a standard facility processing 50,000 wafers per month, demand rises from 35,000 cubic meters per hour at 28 nanometers to 115,000 cubic meters per hour at 3 nanometers. This gas must achieve 99.9999% purity to prevent wafer oxidation in process chambers. Even part per billion levels of moisture contamination will ruin entire production runs. Operating a 3-nanometer air separation unit requires a continuous electrical load of 38.5 megawatts. This massive power draw ties operational costs directly to regional grid stability. To mitigate grid or plant downtime, advanced fabs require up to 46,000 tons of liquid nitrogen backup storage. This volume is necessary to guarantee a minimum 72-hour emergency purge capability. The global supply of advanced cryogenic air separation units is highly consolidated. 3 industrial gas multinationals control 72% of the market and over 85% of advanced engineering, procurement, and construction capacity. Linde leads the sector with a 32% market share and is managing 14 active Mega-Fab projects. This concentration stretches specialized cryogenic engineering teams to their physical limits. Regional Chinese firms hold 12% of the general market, but lack the technical capacity to deliver high-purity nitrogen at scale. Their engineering capability is rated at just 4.5 out of 10. Consequently, Western and East Asian semiconductor sovereignty plans remain structurally dependent on a narrow oligopoly of industrial gas engineers.